After, basically, we have a passive house, extreme comfort. They're in dreamland, sublime indoor air quality. They have allergies. They can actually sleep now. It's amazing, okay? And you can heat it with a hairdryer. Okay. So let's look at a few, let's see if I have these up. Because this is a case I didn't want to take to the last time to show you, but this is maybe a little more interesting. So I'm very quickly going to show construction photos. So you saw the outside, very typical ranch, low slope, stucco cladding exterior. There it is, stucco, old single pane, metal frame windows, old tar and gravel roof. Okay, so inside here you see the oops, went too fast. I wonder, where's my other one? My other weapon here. You see the 2x8 tongue and groove over the 4x8 ceiling beams, kind of dark inside. Got an old fireplace in here, big thermal bridge, an old combustion furnace, gas atmospheric combustion furnace, and a crawl space, no insulation, anything, really tight but clean and dry. Okay, so blower door test in. Okay, this is all Department of Energy, the protocol. This is test in. You'll see the numbers later. 2,985 CFM, about 12 air changes per hour at 50 pascals. Really leaky. Okay, so we cut off the cladding here, diamond saws. We demo the fireplace out, strip drywall, pretty standard remodel. Here you see a little termite damage. This is 50 years, so we had to replace some of that. Again, strip down to the studs, cut off the roof. Strip off this little bit of fuzzy stuff down to the decking. Okay, all the last bin of tear off. Got some lumber and ready to start building again. Okay, one of the things here you can see very common. You have rafter tails. In this case, they're ceiling beams. Okay, that stick out. It's a structural member that goes from the interior directly to the exterior. It's a thermal bridge, and it makes air sealing difficult. So it's called a chainsaw retrofit, but it really should. Seriously, Harold Orr pioneered this in Canada. It's called a chainsaw retrofit. It should be called a sawzall retrofit, but because chainsaws don't work too well on dried lumber. But okay, so all of this existing roof eave in the same way on the gable ends, stripped off, just pared right back down to the frame, other side as well. So now we have a frame, okay, that is essentially a box. It's a frame box, all right? And you'll see why we do that. Inside, again, we're stripped and you build up. We shipped a couple walls, put in a beam, and we start building again. So here you see a piece of sheathing that goes on the outside. Here you see 2x6 rough floor, all kinds of existing gaps and holes. It's sort of an air sealing nightmare, if you will. And we come back with a rubber gasket and a bead of foam. Okay, here's the foam bead and the gasket, so that when we put the sheathing back on, we have the best seal we can get to the floor plane of the floor. Okay, here comes insulation. There's a semi of rigid insulation going up the ramp. There it is, staged on the roof. Now the sheathed, we start taking this plywood box, this wood box, and we start again air sealing. It's air sealed at the bottom, as you saw before. We're air sealing all the joints because this is our air barrier. This is what we call our pressure boundary. Over the top, now we have a simple box. We don't have any structural members protruding. So now we can take a peel and stick, if you will, and we can put it down over the top. I don't know that this one actually wasn't even peel and stick, but it's a sort of an asphalt-based one. So now we have a really simple box with a very simple air seal. We put an eave on it by cantilevering some Infinite H plywood. There's other ways to do it. That's the way we did it on this. Put some blocking in for putting fascia, and we start building up the roof with rigid insulation. This is polyiso, very common in commercial roofing for over insulation. And here we go. It's being built up in layers to about 6 inches. There it is, 6 inches on the main part of the house. Roof decking, all being sealed.
What's the ROI on the insulation that you just showed?
Our bed.
Oh, it'll come. I'm going to get to the specs, okay? The roofers come for, it's a low slope, nice, modern membrane roof. Here it is, the turn up. They have their sealing equipment, etc. These roofs are guaranteed for life. They're wonderful. And here we go. Now, we got the roof insulation. Now we come back to the air-sealed plywood, and we put 2 inches of the same polyiso rigid on the outside because we have a 2x4 frame, which is not very deep. So we added 2 inches that we cap nailed. Here it is all installed. We seal all the gaps. So, we start the flashing because this is going to become our, here it is, sealing around. We use a wet flashing system around the opening. Same system that Dan used here on this building. Okay, and we come over and now we can spray and roll a couple of layers of a liquid applied weather barrier. Just one way. You could use a sheet good like Tyvek, but we prefer this. We think it's better. So there it is. Now we have a weather barrier. On the underneath side, we have 4 inches of rigid polyiso that's been applied to the underfloor area as well. Okay, windows go in. Flashing details. Data logging equipment. There's temperature sensors. Cladding on the outside and so forth, some details in the sills, nice kind of sleek modern look. They wanted a nice modern look in the building. Test out with the blower door, we'll go over that in a minute. Here's the data logger inside the closet, which this is where the furnace used to be. Now they have a whole new closet, right? Because they don't need the furnace. This is important. Real estate's important. And when we talk about this building, a lot of the decisions, the things that were done in this building were because, let's say, because of real estate and daylighting and so forth. Very clever. One of the great benefits of this approach, and the HRV, the ventilation system is up above here, and you could fit it so they had a full coat closet and everything. So big benefit. There it is, up above, actually. And we got coats hanging in front of it. So full closet was gained. Now, we'll talk quickly, because one of the things about these buildings, again, is you can take a different approach toward space conditioning, because it's a low energy building. And so we'll introduce this concept here mostly because it's really important in this building, because we follow the sort of the same concept in a way. So here you see, these are pictures of the supply. This is fresh air coming into the main common area, just like this grill here has fresh air coming into this common area. Here is the heat pump. Okay, just a wall sitting up on the wall, much like that one is right there. So that's heating and cooling, right? And then down the hallway, and you'll see here in the kitchen, there is a fan, a super high performance DC fan that takes about 15 watts that is providing continuous air circulation, and I'll explain why. So here's a rough kitchen. Again, and in the bedrooms, the same thing. There's a little air circulation in, and exhaust relief, okay? And here's in the hallway, okay? And we did some nice things, It's not all about performance. We had some beautiful floors and a nice modern Euro kitchen with German appliances and, lots of neat, sexy, walnut details and so forth too. We're not just building science kids. We love to cook and we love the cool stuff as well. The neat surfaces, very sleek Japanese hardware, and so none of this stuff is incompatible with really cool looking buildings. All right? Euro style bathroom, kind of a neat, this is mid-century modern. This is again all walnut and so on and so forth. And there's the modern exterior with the insulated roof and what have you. Okay.
What would you estimate